So if you went back 100,000 years, you'd see a landscape not too different to what you'd see in the Australian bush or even wandering up the hill today. And so you'd look around, you'd see galahs, goannas, grey kangaroos. But alongside them, you'd see some unfamiliar characters, like Procoptodon here, one of the short-faced kangaroos. And we know about these animals because of exceptional fossil deposits in places like Narracourt down the road, where we actually find 10 different species of these short-faced kangaroos living alongside another 10 or so species of the long-faced kangaroos most of us are more familiar with. And that makes us wonder, why is it that the long-faced kangaroos have survived to today while the short-faced kangaroos went extinct? And I want to address this by looking at a slightly different avenue, and that's the diet of these species. That's because diet is one of the most central elements of an animal's biology. It tells us where it lives and how it spends its day. And in particular, I want to test a well-established hypothesis for these short-faced kangaroos, and that's that because of their shortened face, they're more likely to be browsing herbivores, so selectively feeding on leaves of trees and shrubs, rather than grazing on grasses like most long-faced kangaroos do today. And the method I'm using to investigate this is known as dental microwear. And this works because whenever an animal chews its food, the food makes microscopic scratches on the surface of their teeth. And the shape of these scratches are different for different sorts of foods. So if I take one of those teeth, scan it in high resolution in 3 dimensions, like we can see here, we can then run algorithms across that surface that differentiate for different diets. And that's what we've done for kangaroos, where as you see more and more browsing the diet, you actually see an increase in this microwear measure here. And when we add fossil species into the mix, you can see that firstly, for the short-faced kangaroos, we do have a strong browse signature, stronger than you see for any kangaroo around today. But at the same time, we've actually got a sort of similar signature coming out of the long-faced kangaroos from the same deposit. But this sort of makes sense because we know that this deposit accumulated over a huge amount of time, a time period that we know correlates with large-scale changes in climate. And so what we're really seeing is that while the short-faced kangaroos might be better adapted to browsing and the long-faced kangaroos better adapted to grazing, both these groups adjust their diet to whatever vegetation is around at the time. And this is probably an adaptation to the highly variable nature of the Australian landscape. And this also has take-home messages for both modern kangaroos, where we can actually use this dietary flexibility as resilience in the face of climate change, where we'd expect vegetation conditions to continue to change. But for the short-faced kangaroos, it means that their extinction is unlikely to be tied to the loss of a single resource like a plant group. And instead, we might need to look elsewhere, in particular, the arrival of humans in Australia. Thanks for listening.